Standards for drawing orthographic views on prints are detailed in the American Society of Mechanical Engineers publication Y14.3, Orthographic and Pictorial Views. This standard covers all orthographic views, whether one of the 6 principal views or an auxiliary view. Auxiliary views will be introduced and discussed in this unit, but we will begin with a quick review of the important principles of reading multi-view drawings in general. Recall from a previous unit that the views of an object are developed by projecting the object's surfaces onto an imaginary plane called a viewing plane. Viewing planes can be visualized as panes of glass through which the object is viewed from different perspectives. Also, when the projectors are perpendicular to the viewing plane, the projection is called an orthographic projection. For example, to create an orthographic projection of the highlighted surface onto the viewing plane shown, we use projection lines from each point on the surface to the viewing plane. These projectors must be perpendicular to the viewing plane. When the surface is projected onto the viewing plane, the resulting view can be drawn with the correct orientation. Since in this example the surface on the object is parallel to the viewing plane, this surface will appear in true size and shape when the view is drawn. If the original viewing plane is defined to be the frontal viewing plane, then the view projected onto this plane is the front view. Similarly, the right side view can be projected onto the profile viewing plane, while the top view is projected onto the horizontal viewing plane. If the viewing planes are then unhinged and laid out on a flat surface, the corresponding views will appear on the print in their expected location and all in orthographic projection with each other. To learn to interpret auxiliary views, you will need to recall these important principles of orthographic projection. First, surfaces that are parallel with viewing planes appear true size and shape in the corresponding view. Second, surfaces that are perpendicular to viewing planes appear as lines in the corresponding view. Third, surfaces that are inclined to the viewing planes appear foreshortened in the corresponding view. You have learned that there are 6 principal views defined by standard ASME Y14.3. These are the front, right side, top, left side, bottom, and rear views. If present on a print, these views all have a defined location relative to each other. The principal views are rarely labeled because it is expected that the print reader can identify any of the 6 principal views by its location on the print. If a view is not located in one of these locations, then it is classified as an auxiliary view. Here is one type of auxiliary view you are already familiar with, a section view. Since this section view is not drawn in a location where we would expect one of the 6 principal views, or in orthographic projection with any of them, it must be labeled to help the print reader interpret its meaning. This type of an auxiliary view may be drawn at a different scale than the principal views. But not all section views are classified as auxiliary views. Sometimes a section view can also serve as one of the 6 principal views. Here, the left side view is also a section view, but it would not be referred to as an auxiliary view. In this case, the section view must be drawn to the same scale as, and in orthographic projection with, the other principal views. So one common use of an auxiliary view is to show a cross-section of an object, but not all section views are auxiliary views. Another use of an auxiliary view is to show an inclined surface in true size and shape. Here is another type of auxiliary view, which is drawn by orthographic projection from the front view. It is not directly replacing the top view, although no top view is shown on this print. Notice that this auxiliary view is not labeled. In this case, it is recognized as an auxiliary view because it is not in the expected location of one of the 6 principal views, and it is drawn in orthographic projection with only one of the principal views. Its purpose is to show an inclined surface in true size and shape. The inclined surface appears as a line in the front view, as a foreshortened shape in the right side view, and in true size and shape only in the auxiliary view. This type of auxiliary view is usually drawn when the inclined surface includes features that need to be dimensioned. We will discuss the standards for dimensioning a drawing in a later unit, but one principle is that features should be dimensioned in a view in which they appear as true size and shape. Here's an example that illustrates this second common use of an auxiliary view. Here's an object that includes an inclined surface. this surface is perpendicular to the frontal viewing plane, so it appears as a line when projected onto this plane. Since the front view is developed from the image projected onto the frontal viewing plane, the inclined surface will also appear as a line in the front view. Notice that the surface is inclined to the profile viewing plane. As a result, when projected onto the profile viewing plane, the inclined surface appears foreshortened. Since the right side view is developed from the image projected onto the profile viewing plane, the inclined surface will also appear foreshortened in the right side view. This surface is also inclined to the horizontal viewing plane, so it is also foreshortened when projected onto this viewing plane. Since the top view is developed from the image projected onto the horizontal viewing plane, the inclined surface will also appear foreshortened in the top view. Remember, because the surface is perpendicular to the frontal viewing plane, it appears as a line in the front view. And because the surface is inclined to both the profile and horizontal viewing planes, it appears as a foreshortened shape in both the right side and top views. Since the inclined surface is not parallel or perpendicular to any of the regular viewing planes, frontal, profile, or horizontal, it will not appear in true size and shape in any of the regular views, front, right side, or top. In order to see this inclined surface in true size and shape, an additional viewing plane is required. This viewing plane is oriented parallel to the inclined surface and is called an auxiliary viewing plane. When the object is projected onto this auxiliary viewing plane, the resulting view shows the inclined surface in true size and shape. This is one very common reason many prints include auxiliary views, to show the true size and shape of an inclined surface. Auxiliary views may also be used to show the angle between two surfaces in true size and shape. Consider a V-shaped groove cut into a surface. The two surfaces that form the sides of the groove intersect at some included angle called their dihedral angle. This angle will only appear in true size and shape if viewed from a perspective looking straight down the axis of the groove. From this point of view, the bottom of the groove appears as a single point. If the perspective is shifted from this point of view, the bottom of the groove appears as a hidden line. Then the dihedral angle will not be seen in true size and shape. If an auxiliary viewing plane is oriented so that the bottom edge of the V-groove appears as a single point, then the dihedral angle can be drawn in true size and shape in the resulting auxiliary view. Here is an example of an object with a V-groove that can be seen in the front view. In the right side view, the groove is seen, but the bottom of the V-groove appears as a line in this view, not as a single point. As we have just seen, this means that the dihedral angle is not true size and shape in the right side view. This is because the surfaces that make up the groove are both inclined and rotated with respect to the profile viewing plane. To show the groove in true size and shape, an auxiliary view is required. Projecting the auxiliary view off of the front view will result in a perspective from which the bottom of the V-groove appears as a single point. Then the V-groove's dihedral angle will be seen in its true size and shape. Last, and in general, auxiliary views may be used to provide any detail or information that is difficult or even impossible to show using only the 6 principal views.